Hey, what's going on, y'all? Sean of MassSwap Tutoring here, and today I am going to talk about the law of detachment. This is a geometry topic specifically having to do with logic as you kind of start to build the case for making proofs and all those kind of fun things. This is kind of like the background for it. You have to kind of like set up your how you make your arguments and proofs and all that kind of stuff. So let's go ahead and get into it. Make sure you like, make sure you subscribe, and let's go. So the law of detachment basically in words is as follows. And I guess I'll write this, okay? So given a conditional statement, if the hypothesis is true, then um let me change that word. I'll say therefore. I don't really like my grammar, but that word is important. The conclusion is true. Okay. All right. So the law of detachment states that if you're given a conditional statement, the hypothesis is true. Therefore, well, I'll say then. Um, Let me just say then, and we'll kind of bring in the word therefore when we need to. Then the conclusion is true. Now, if we want to rewrite this using the symbolic notation, it goes like this. Given a conditional statement. So our conditional statement is like so. You have some statement, if P then Q. Remember, that's what that means. If P, and I'm gonna write those um here to the side in a different color. So you have this conditional statement that says if this happens, then that happens. Okay. If it just so happens that P is indeed is true, so if P is true, okay, then you say these three dots mean therefore Q is true. Okay. So again, so let this make sure this makes sense to you. So you get this conditional statement that if this happens, that happens. If P, then Q. Given that conditional statement, P is true. If P is true, therefore you can conclude that Q is also true. Okay. Because basically we're saying we already know that in a general sense, if this happens and that happens. So in a specific sense, this ends up being true. So automatically Q is true as well, because if P happens, then Q happens. Okay. Keep on listening to that, writing it, watching it until it makes sense to you. One thing I want to encourage you to do is don't try to like just like really try to like read it and understand it. Make sure it makes sense to you. And we're about to do a couple of examples here that will help it to make sense. But there's a way of studying math where you can just try to like remember it just kind of based on like a very shallow kind of like, okay, I have to write this stuff down and this is the answer. If P, then Q, P, therefore Q, but you have no depth of understanding. Make it make sense to you. Read it and say, does this make sense to me? Okay. Now, examples will help it to make sense. So let's give a couple of examples here. All right. So let's say that you have the following conditional statement. Okay. Real world example, so to speak. If it snows, then school will be canceled. Okay. So you have your conditional statement. You have your hypothesis, which always follows the if, and then you have your conclusion, which always follows the then. Okay. If it snows, then school will be canceled. All right. Well, um, school is canceled. I mean, no, no, no. I didn't mean to do that one. I'm kind of, I was looking at the wrong. It snows. Okay. So say, for example, you look at this as kind of like a rule. If it snows, then school will be canceled. Then one day it snows. So P happens to be true in this particular instance. Therefore, based on the law of detachment, you can conclude that school will be canceled. And it's probably helpful to label these as you go, okay? So it snows, that's your P, Q, school be canceled. Then it snows P, so P is true, therefore Q. And so that'll help you to kind of like know that this is indeed the law of detachment. Okay. All right. Now let's do another example here. Okay. All right. So if it snows, then school will be canceled. Okay. All right. So again, let's label these. Here's your hypothesis. Here's your conclusion. Let me also go ahead and put like a line here to separate these examples. Okay. Now, let's go for the next part of this. Okay. School is canceled. Okay. Now, what is school is canceled? Is that P or Q? That's Q. Okay. So let's label that. Now, the law of detachment states that if P then Q and then P is true, therefore Q is true. It doesn't say Q is true, and then you can conclude that P is true. It doesn't say that. So therefore, there is no conclusion. Based on the law of detachment, you can't make a conclusion from that. And even, sorry, even if you think about it logically, um, just because school is canceled doesn't mean that it is canceled because it snows. It could be other situations. So that's why you can't really make this conclusion. But it has to be if P then Q, and then you determine that P itself is true because P leads to Q. There is no situation. This doesn't say that Q leads to P, if that makes sense. All right, let's do one more example here. Let me do another line. Then we're going to scroll on down. All right. So let's go again. If it snows, then school will be canceled. Okay. It does not snow. Okay. So let's label this here. If it snows, so here is our hypothesis. Here is our conclusion. What is this? So our hypothesis is it snows. In this case, it says it does not snow. So this is really not P. It's not. This is not P. Okay. In other words, P is not true. Okay. So can we conclude, for example, from the law of detachment that school will not be canceled. No, we can't. All you can conclude is with the law of attachment, if P then Q, P is true, therefore Q is true. You can't conclude that P is not true, therefore Q is not true. You can't do that. Okay. So this would also be a situation where you have no conclusion. Okay. Because again, now think about it logically. Just because it doesn't snow doesn't necessarily mean school won't be canceled. Because again, it could be some sort of other situation like some sort of rainstorm where school got canceled or whatever. So that's why it has to work this way. So just to recap again, I meant to select this here. So if P then Q is your conditional statement that you're given, then when P is true, therefore you can conclude that Q is true as well. Okay. Hopefully this helps. Watch the video again and again to make it make sense to you. Don't just try to memorize the stuff so you can write it down for a test. Make it make sense. It's good mental exercise. Like the video, subscribe to the channel, share the video with your friends, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.